Hi again, Rob Moody. How are you today?
I am good, Chantal. How are you?
I'm great. It's so nice to see you again, and it's been a little while.
It has, but we enjoyed all the more, don't we?
We do. Good things are worth waiting for, aren't they?
Surely are.
Yeah, good. So today we're looking at our episode 2 on IPMX. And it's really nice to talk about IPMX because it's definitely becoming so much more popular and everybody wants to learn more about it. So let's do this. What I'd like to do today is look at the different open standards. I want to include ST2110, NDI, and IPMX. Very, very popular. And what I'd like to do with you is sort of explore how they're shaping the convergence between Pro AV and broadcast. Hopefully, that'll make it clear after our podcast why these open standards should be on the radar for everyone. And anyone, certainly, who's looking to operate in a hybrid future. So
Of
let's
course.
start with the standards. And first things first, Rob, what is a standard?
Well, we could look to ISO, the International Standards Organization for Standardization, and see what they define as a standard. And if we did, and I'm going to read this now, it's a document
Mhm.
that provides requirements, specifications, guidelines, or characteristics that can be used consistently to ensure that materials, products, processes, and services are fit for their purpose. Well, that's a mouthful, isn't it?
It sure is. Okay. A document that tells us what to do.
Why
So why
didn't
do
they
we need
say
them?
that, huh?
I know, right? So why do we need them? Can't we just figure this out for ourselves? We're all smart people.
Well, we are, and of course, what often happens when you put a bunch of smart people in the same room is you come up with a good idea. And quite often, the good idea came from problems that needed a solution. And what happens is that idea gets taken up by several different organisations and developed independently. And then, of course, they all end up in different places. They've created things, hopefully good and useful solutions to the original problem, but quite simply, they don't work with each other. And that's why we have the standards to ensure that everyone ends up in the same place. Clearly, it's very important for, say, the broadcasters to be able to exchange video between each other and that everyone should see the same images. The Olympic Games, of course, is a classic example where the content's created locally and then shared globally.
Yes, the Olympics. Yes, so I can see that standards are obviously good. Do they all follow the same procedure? Is there sort of a standard for making standards?
Good idea. And it turns out that there are ultimately several sorts of standards. Some of them are governmental, legislative, if you like. For example, for a car to be on the road, it's got to meet a number of standards. Those are the sort of standards that have got legal force. Some standards are made by organisations that make their money purely from selling standards. The standard, if you like, is their product. We might think of organisations like ANSI or ISO in that environment. Another sort of standard is where an organisation has created a product and everyone starts using it in preference to others. Those are called de facto standards. In some cases, those standards require the use of a particular element, like a chip or a patented aspect. There's an implied sale behind it, and that's both a strength and a weakness. If the company goes down, the standard often sinks with them. In our AV world, HDMI is the one we all recognise. We all use it. It's administered by an alliance of companies who actually derive a license fee from each connector sold. The connector design itself is protected. Of course, in word processing, the .doc format's an industry standard. That's a particular sort of de facto standard. Everyone uses it, and everyone expects others to use it. It's ultimately controlled by Microsoft, of course. And your mobile phone, that's probably either Android or iPhone, but those two are de facto standards. No one says you have to, but you do.
Yes, yes. I'm an iPhone gal myself, but the Matrox phone is an Android, so I've got both actually.
Well, yes, cover all bases.
That's right. So, how does that relate to open standards? We're talking about standards, but we're now I want to sort of shift to open standards and specifications.
Okay. Open standards are not bought and sold as a document. They're not steered towards a particular device, which becomes a mandatory purchase, if you like.
Hmm. Hmm.
There's no essential patent that requires a license, and yeah, it's open, not closed. There's no particular organizer, company, or manufacturer that's in the driving seat for it. Because it's open, everyone can see what's happening. And of course, the wise and the good, whether they're there in an individual capacity or with the blessing and support of their employer, can join the group and then contribute their expertise. And in the case of the subjects that we wanted to talk about here, as you said, ST2110, well, that belongs to SMPTE, Society of Motion Picture and Television Engineers. That's not aligned to any manufacturer. IPMX belongs to AIMS, an alliance where there are no guaranteed seats at the table. Again, it's not aligned to any manufacturer, nor do they make any profit from anyone adopting those standards.
And is an open standard the same as interoperability?
You might think so. It's not quite the same. In history, we've seen a number of organisations try to create interoperability via what they hope will become a de facto standard. But at the end of the day, it's a closed standard. They tried to create, in other words, a revenue stream that delivered interoperability. Perhaps their chip was in the middle. What they managed was a product that was versatile, but was always aligned with what they wanted. And some people, when they hear interoperability being talked about, tend to think, oh, that again. And what open standards do is to approach it the other way round, create real multi-vendor interoperability first, which subsequently delivers a revenue stream. So that's the approach that puts the emphasis on the true interoperability, which then derives the revenue. It's a subtle difference, but it's pretty important.
Sure, absolutely. Absolutely, revenue is important. So, what are some of the driving forces behind the development of open standards?
Well, AV over IP fits into my earlier description of a good idea taken up by different organizations resulting in different products. And in that way, the manufacturers ended up with families of products or stables which worked with each other and didn't work with any other products from other manufacturers. It's a closed standard. Some people call it a silo, some people call it a walled garden. Whichever way you look at it, they just don't work with each other. The silo was a great source of frustration during COVID because finished goods couldn't get out of the factory, and then came the components crisis and raw materials couldn't get into the factory, and both of those global events resulted in super long lead times. But there was no way for the customer to get round it, precisely because they were products built on closed standards, the walled garden, the proprietary product. We also see the same based on a chip sort of standard. And the premise there is that because the core is the same, all the brands using that chip will, of course, be compatible. It's our chip in the middle. The reality is that that isn't quite right because the different manufacturers use the chip differently. They put their own circuitry around the chip. Maybe they don't expose all the possible functionality. And most of those sort of products work together most of the time. But I think probably everyone's got a story to tell about one brand of, say, SDV over E or HD based T that didn't work with one another. And of course, if you can't get the chip, you obviously can't build the product. There is no alternative. And in some instances, we had manufacturers who couldn't ship their product because they couldn't get a chip that enabled a particular feature. So if they were short one feature, couldn't ship the whole product. Open standards is one step removed from that way of doing things because the purpose is not to create the revenue model. HD-based T, of course, is a revenue stream for Valence Semiconductor. If we're looking for an equivalent purpose in open standards, perhaps it's to create a community and create value for all. Manufacturers, for intermediaries, for users, for everybody. And the major value is one that you pointed to earlier, interoperability.
I like the idea of value for all. Definitely interoperability, of course. So maybe now we need to take a step back and talk about what open standards are not.
Very wise. Many people get confused between open standards and other things that have got the word open in them. So it is not open source. That's when people can change the code to create their own code version. Linux is like that. Anyone can edit it, build on it, redistribute it. It's not open core. It's a similar thing, but that allows for partial monetization, a free base, but with chargeable extra features. Open standard is not open data. Wikipedia says open data is data that's openly accessible, exploitable, editable, and shareable by anyone for any purpose. Open data is licensed under an open license, so it's none of the above. Now, I think most people would see that as something they'd want from their government, the ability to see the data upon which the decisions were made. Open source and open core were clearly about the software. Open data is about the information, and open standards are about a specification. There may be a protocol involved, of course, something that tells you how to do things. But open doesn't mean individuals can take it and changing without you knowing. And I think that's a big fear that many have. Standards are subject to revision control by the organisation that's responsible for it. And in the IPMX case, that's AIMS and the VSF.
Perfect, perfect. So now we know what they are not. We know what they are. Let's talk about the different open standards that I mentioned earlier. So we've got ST 2110, NDI, and IPMX that we wanted to cover today. So how do they compare?
Okay, so a lot of people think that because all of these approaches are about moving the audio and video assets over IP, they're basically the same thing. And that's not at all the same case. They were each designed to do different things. But interestingly, all of them recognize that their users can have different needs.
Ah, so you're saying that some users' view of what makes content sort of good enough is different, and that ST2110, NDI, and IPMX are all open standards, but with different users in mind, yes?
That's exactly what I'm saying. So let's break it up a bit and start with ST2110.
Okay.
ST2110 starts from the position that they want to move uncompressed video in real time, just as their users did with SDI over coax cable.
Hmm.
The objective is to deliver the same quality, uncompressed, meaning not just no artifacts, but editable at any point, negligible latency, fast switching speed, and with synchronization sufficient to enable seamless switching at any point. So that's what 2110 is aiming to do with its uncompressed. And if you do the math just on the pixels, you soon find that you'll need around 12 gigabits per second to support 8-bit UHD. That's what the 12 means in 12G SDI. And it means it doesn't fit into a 10 gigabit per second pipe. It needs a 25 gigabit per second pipe. They identified a secondary user need group, and those are some folks who can live with light compression. And that's where JPEG XS comes in.
So, yes, so ST2110 isn't about just one user group then. It's actually about two user groups.
Exactly right. Now, NDI started from a different place. Their primary objective was to move media into a processing workstation. They assembled a huge ecosystem of applications into that workstation. Zero latency, however, was not an objective. There was still processing and switching to be done. And the precision of the synchronization enjoyed by 2110 was not part of the design brief for NDI either. There was a sort of side objective that the workstation should have a 1 gigabit per second network, and that decision meant, firstly, it was not going to support uncompressed UHD material. We saw that needed 12 gigs. And second, that the compression method would limit exactly where a cut could be made. It needed to be at a certain point in the group of pictures in the stream. Initially, they used their own in-house codec, the definition of a closed system. They subsequently identified two more distinct groups of users, typified by the use of H.264 and HEVC codecs, and that's how NDI ended up with three varieties, corresponding to three supported codecs, three user groups, but in their case, all within the 1 gigabit per second pipe, running from 200 megabits per second downwards.
Aha. So NDI has three varieties of users, but they actually don't overlap at all with the two user groups in ST2110.
Yep, so some of the other AV over IP solutions pursued some users who needed smaller latencies and faster switching, and they needed to use higher bandwidth to do that, some at the 800 megabits per second point, still on a 1 gig network, and others needing to move up to 10 gigabits per second as the network costs started to come down there.
Yes. Okay. So that makes sense. So we're seeing a lot of different user needs, correct? Is there an answer to this, all of these needs?
Well, the purpose of IPMX is extracted away from the workstation. It's all about the movement across the network. So it's able to take a much wider view of the types of users, recognizing that there are groups of media users who are limited by bandwidth and don't care about synchronization so much, as well as those who've got much higher ambition, all the way up to uncompressed. So IPMX supports 1 and 2.5 and 10 and 25 gigabits per second if the user needs or wants them. And it supports a variety of synchronization methods. And the standards have been written in anticipation of even higher resolution and higher bandwidth in the future, and none of us know where we're going to end up. It's an uncertain world here. Nobody's using 32K by 32K streams today, but the standards have been prepared with that in mind. So if they start down this path, they won't find themselves boxed in.
Right, right. Well, anticipation of future sounds like a real benefit, obviously. What are some of the other benefits of open standards, and are there any drawbacks?
Anyone who was limited by the inability to get their favourite brand during COVID and the components crisis would clearly have benefited from substitutability, open standards. They would simply have chosen another brand that they could get. With IPMX and its interoperability, users would have had their systems earlier. That's users' benefit. Integrators would have been able to complete projects sooner and be paid earlier. That's an integrator benefit. So there's benefits for everyone in this. There are some who would say if you want to go fast, go alone. If you want to go far, go together. The idea is that going together benefits from having multiple perspectives and is less likely to go down a blind alley. Sounds good. The corollary of this is that the evolution of open standards needs discussion before you get to the agreement, of course, and that takes time. It also needs organisations that are prepared to invest in the future of an industry and a community rather than simply their own future.
Right. So, if I'm understanding you, one very noticeable drawback of open standards is that because the intent is not to create a revenue stream right away, not even selling the standard, there's no corporate marketing department trying to promote or sell IPMX. So, growth actually relies mainly on the participants spreading the word. But when the word is good, it does travel, does it not?
It absolutely does. And I think it's a very interesting observation that the organisations who adopt these open standards do want to create a revenue stream for themselves, of course. They're businesses after all. So you have the fascinating spectacle of companies that are actually developing to the open standard. They're committed to it, but they're behind the curve. And they spend a lot of public effort trying to slow down those who are ahead of them by suggesting it's too soon to jump on the train just yet. And then magically, when they finish their development, it will be exactly the right time to adopt the new standard.
Indeed. Go figure. So tell me, what are some examples of implementations or applications that could actually benefit from open standards?
Well, everyone can benefit. We obviously saw the users and the integrators earlier. But in the case of these particular standards, we can recognize some examples that benefit more than others. The classic examples are the convergence of broadcast and AV. So the sort of environment where an ST2110 network already exists benefits strongly from having compatible AV networks like IPMX going away from the studio complex. It means that the internal messaging can come straight from the source, the studio, to group meeting and watching areas around the real estate without leaving the network environment. Another one, imagine the large international bank. They've got a high-end studio for the chief economist to do interviews with the media, a studio which also produces marketing, training, and other video assets that are viewed around the organization. In fact, don't imagine the largest bank in the Western world has done exactly that. The largest insurance company in the world has done exactly that. And these sort of organizations tend to adopt the new technology in their flagship sites and then roll it out globally.
I can also imagine that entertainment venues might benefit. They too characterize the merging of AV and broadcast thinking. They often need ultra low latency and synchronization. Perhaps a situation where the individual members of a large orchestra can only see the conductor clearly via a dedicated video link. Equally, the repeater screens that the audience sees need to correspond to exactly what they can see happening live on stage. The same is not true, however, for the repeater screens in sort of the restaurant or the bar areas or in holding areas for the latecomers. They can't see the stage, so they don't have to see it at the same time as what's happening live. So I'm recognizing the different needs, aren't I? They don't all need or indeed get the ultimate performance.
Absolutely right. Yeah, that's different needs in the same place. We've also seen deployments in surgical training establishments. High quality imagery there of a particular student's progress as they operate can be shared between the students in the same class by the lecturer, together with the lecturer's commentary. It's a dramatic step forward from all the students being asked to gather round a single table to then only get a partial view over as they watch what's happening over somebody else's shoulder.
Right. And that sounds like progressive thinking in action. What does a future based on open standards look like?
Oh, crystal ball time.
Yes.
The so the global rollouts that I was referring to have started. So that's the immediate future. It's sort of happening now. And to them, the future looks just like the system they have at the mothership. What about the others? Well, as the mists in my crystal ball start to clear, the good news is that the future is as I think we would all want it to be. We can have our favorite brand if we want to.
So we can select a product based on feature set. Just because it is open standard doesn't mean all products have the same features. So we can match features to our needs, and that might include cross brand interworking.
It may indeed. So we've got cross technology and cross brand. Both are delivered by IPMX. So we can select product on any criteria we value: cost of ownership, country of origin, cybersecurity, reliability, support, the favorite brand we've had for years and years, and so on and so forth. And even having chosen in that way, we can still have the interoperability. The standard was designed for the future, not just your last project. So reuse of equipment that has not reached EOL is very viable. A dramatic contribution to the sustainability that should be important to us as well. So you weren't expecting that out of a discussion on standards.
No, not at all. So sustainability is important. You mentioned crystal ball time. I know a lot of integrators who don't need a crystal ball. Their clients already have an overall objective in terms of their AV over IP strategy. They don't intend to implement it as an overnight replacement, certainly. In other words, getting the ROI from AV over IP kit they already have installed is important. Kit that's not currently interoperable. So some kit is going to be there for a while yet. How will that kit interface to the brave new world of open standards based AV over IP?
Good question. And a very common scenario. Of course, there's the what we might call the default interoperability going via SDI or HDMI between the new and the old, exiting the first, patching across, re-encoding into the second. But that takes the assets out of the network. So you've lost the ability to control it, to monitor it, and to secure it because it's not in the network. It's clearly better if the assets can stay in the network until you need to consume them. So in that case, the future includes gateway devices between the old and the new systems. For example, a device that can take NDI in and interface it to a system that's expecting, say, SRT or hopefully IPMX in the future.
I know you're thinking about the Matrox Vion, yes?
I am indeed. I'm very excited by that. Um, in the limit, you could see devices that are funneling almost everything else into, say, IPMX or whatever the organization's chosen strategy is. And of course, that's a whole lot easier if everything else is sufficiently open for a third party to be able to create the conversion, as we've done with Vion. Those that still want to be a silo will probably not cooperate with creating those sort of bridging devices, these IP to IP gateways, as we like to call them, which is a shame because staying in their walled garden, as attractive as it is, means they may well get left behind.
Yeah, it seems to me that the open standard garden is a very attractive place to be, interoperable across brands and across the whole of enterprises, as well as being future proof and good for the environment.
Yep,
And it is at the heart of the merging of broadcast and AV thinking. So, what else is there to say?
I can think of lots more, but I think I'll keep that for the next edition.
Excellent. I think that's a great idea. So, let's gather again for episode 3.
Surely will. Look forward to
Looking
it.
forward to it. Bye bye.